everyone. Good morning, good afternoon, good evening, depending upon wherever you are in this part of the world. My name is Saurabh Kumar, and I'm a second officer with an airline based in the Middle East. And I have started this series on A320 system knowledge, wherein we'll be covering all the major systems, all the subjects, with the help of the FCOM and various external resources. And my idea is to share knowledge and refresh my knowledge and learn it from all the aviators out over there, and also to answer the questions of any curious or budding aviators who would like to learn a little more about the aviation field. So before I start this course, let me just make it very clear that this is just my personal perspective, and I'm trying to basically share what I know. So there may be a few cases where I could be wrong. So always verify all the facts and all the knowledge before you actually document something. And please feel free to give any open criticism and constructive criticism so that we can all learn from each other and I can continue to make these videos better and better going forward. So without any further ado, let's begin. So the Airbus A320, okay, this is going to be the general module, and we are going to be speaking about very simple things basically. What is A320 essentially? So Airbus A320 is a passenger aircraft. It is a general aviation airplane and a scheduled airplane as well, which means that it's a scheduled carrier which carries transportation of civilian passengers and the cargo goods. So the A320 is subsonic, which means that it travels at a speed which is lesser than the speed of sound, which is 1 Mach. And it's a medium range aircraft. Typically, it has a range of about 8 to 10 hours, depending upon the fuel tank capacity, and it's a civil transport aircraft. It has two engines depending upon the airline choice. It can choose either the CFM engines or the IAE engines, which are mounted underneath the wing. The cockpit is designed for 2 crew, and there are 2 additional or 1 additional seat for basically observer. The cabin is a single aisle, which means that there is only 1 aisle through which you can walk through. There are seats 3 abreast on each side, and the total number of seats can vary anywhere from 160 to 180 at full capacity, again depending upon the requirements of the airline. It has 2 cargo compartment doors, and the doors are located on the right side of the aircraft. There's a forward door and there's a rear door. Just some dimensions about the A320. So if you see the total length of the airplane, it's about 37.57 meters long, and we are concerned about the length largely, and that is 37 in terms of the length of the aircraft. And if you look at the wingspan, which is right here in the third image from top, 34.1 meters. Wingspan is important because you want to understand how much clearance do you have, so that you don't get a wingtip to wingtip collision, which usually happens on the ramp, especially if the parking spaces are very cramped together. So it's important to understand largely how long or how wide is your airplane, and then there are a bunch of other dimensions, such as what is the ground clearance for the engines, how far above the pilot sits from the ground, and what is the length from nose wheel to nose wheel. It's largely required for the engineering, as they need to understand how the aircraft is basically structurally designed and integrated all together, and then they basically measure the various clearances from various reference points on the aircraft. This particular diagram shows the pressurized and the unpressurized areas of the airplane. So if you see the nose of the airplane, which is where we have the weather radar located, the nose gear bay, which is where the nose wheel will be stored inside, the air conditioning compartments, we have 2 air conditioning packs, and we will talk more about it in the air conditioning module. The main gear bay and the tail cone are unpressurized. The reason being that you don't have passengers in these areas, there is no cargo stored, and you don't need to pressurize these areas, since that comes at a high cost in terms of fuel burn, because you would need bleed air, which means the engines will have to generate and pump in more air in order to pressurize these areas. And hence the Airbus designers decided that it is better to leave these areas as unpressurized. The cargo compartments though are pressurized, so which means that we can carry live animals and perishable products as well in the cargo compartment. The second one basically shows the location of the antennas. There are a lot of antennas located on top and below the airplane, some in the nose gear, some at the empennage or the tail of the airplane. You can see that HF1 and 2 radio and VOR, which is very high frequency omnidirectional radio, is located at the top of the tail. And we have GPS 1 and 2, which is located above the fuselage, and the ILS and localizer, which we use in most of our approaches while landing, are located at the front radome area. And then we have distance measuring equipment again, which is located below. TCAS, interesting one, which is one above and one below, since we need to understand the traffic in the vicinity, how much traffic do we have above and how far is the traffic below. Here we see the ground service connections and panels. So in total we have 12, and here is the legend. So the different panels which can be opened from the outside of the airplane for refueling, hydraulic, toilet servicing, and APU servicing, APU oil filling, a bunch of other openings outside the airplane as well. And largely these are used by the ground staff, for example for the cargo, for refueling, for toilet servicing, and by the maintenance for the servicing and changing of the oil, or refilling of the hydraulic liquids for the different lines. Here we see what is the turning radius required by the A320 from various reference points. So here they have considered the left gear to be the focal point, which means that the aircraft would define this much of a radius, which is denoted by R4, R5, R3, with different lengths, and the center of this radius starts from basically the left gear, which is located below the left wing. Just to understand basically what is the minimum width of the taxiway of the runway which you require in order to make a complete 180 degree or 360 degree turn. So for A380, if you have to make a 180 degree turn, you need a minimum of 30 meters wide of the path, which is the taxiway or the runway, which is just a good number to remember. The 30 meters is minimum that I require if I have to safely make this complete 180 degree turn. And this is useful when you have to backtrack on the runway in case you don't have a taxiway link which connects you to the threshold point of the runway. So you'll have to basically use an intersection, a taxiway, and backtrack on the runway, and then make a 180 degree turn in order to face the runway which is being used for takeoff. Again, a bunch of numbers which are mentioned over here in feet and in meters as well. So 180 degrees turn on the runway. With the recommended 180 degrees turn technique on a dry runway, the approximate turn width is 24 meters. So you need about 24 meters, but 30 meters is something which is good enough with the additional 6 meters of safety margin. The flight crew should consider additional margin when the runway is wet or contaminated, of course, because there is a chance that the wheel might slip, and hence you need a little wider runway. But the minimum that is required by A320 for 180 degree turn is 30 meters of wide runway. And there is a separate technique in order to make this 180 degrees turn on the runway, which we can talk about later, or in case if you would like to know more about it, I can show it in one of the next videos. Here is the ground clearance diagram. Again, it basically shows so the magenta line basically shows with shock absorber fully compressed, and the blue line is with fully extended, and the A, B, C, D points, as we can see, are the contact points for the fuselage, stabilizer, wingtip, and nacelle. So where exactly would it touch on the ground at which given body pitch up angle of the airplane? So basically, to think about is, if you pitch the aircraft, let's say if I'm referring to the purple line, and if we look at point A, which is the landing gear and rear fuselage with shock absorber fully compressed. So A is the point where the rear fuselage would touch if my body roll angle is close to 4 degrees with a body pitch up angle of about, let's say, 12.5 degrees. So that's where the there would be a contact point on the landing gear and the rear fuselage, and so on with point B, which is the stabilizer. If I continue to increase my body roll angle to about, let's say, 11-12 degrees with a pitch of about 12 degrees, then my stabilizer would touch the ground. That is exactly the point of this diagram. I think this is largely used in order to determine that you don't have tail strikes, or basically don't have high roll angles or high pitch angles, because then you would actually end up touching the ground, and that would actually really scrape the aircraft and cause external damage. This is about final approach and landing geometry. I'm not going to talk much about it, but basically it is largely talking about what is the glide path with various distances. So it is basically measuring the distance between the ground and the landing gear at different phases of the final approach, and where exactly would you land in terms of the touchdown area, and the points A, B, and C. So C is basically your touchdown zone, where exactly you're supposed to be landing at. The B is basically the distance from your touchdown until the glide slope transmitter, and A is the entire distance right from the beginning of the runway until your glide slope transmitter. And it is basically comparing 2.5 degrees glide path versus 3 degrees with ILS antenna at 50 feet at threshold, and no flare and pitch angle 4 degrees. So there are certain conditions used for this particular diagram, and flaps full configuration as well. So essentially what it's saying is that the main gear and antenna at threshold is 37 feet, main gear at threshold is 34 feet, which is your radio altitude indication. Main gear path and pilot is at 56 feet. Final approach and landing geometry. Essentially it's basically trying to show your clearance in terms of your final approach at the time of flare. Minimum visual ground segments, flare phase. Again, it is showing basically how far ahead the pilot can see when you're flaring the aircraft. Again, this is a bit too technical, so I'm not going to go much into it, but it's basically giving you various dimensions in terms of meters and feet of the minimum required visual runway range that you need to have, the obscured part, and the visual segment that you can see for Cat 3 and Cat 2, which are basically different weather minimas. This one is very interesting because this is about how far ahead the pilot can see, or what is the angle. So if you're sitting in the cockpit, you cannot see 12.5 meters or 41 feet ahead measured from the nose of the airplane, and the angle is 20 degrees angle, so you can only see beyond, let's say, 13 meters or 12.5 meters exactly from the nose of the airplane, which is beneath you, until further ahead you will not be able to see, because that is obscured because of the nose of the aircraft. So that was it for the general part of the airplane. We will begin in the next module with the next module, I believe, is going to be air conditioning, pressurization, and ventilation, and this we'll be talking about in the next module. Thank you for watching this quick video on A320 General. I hope you enjoyed the video, and in case you have questions, kindly please put them in the comment section of this particular video. Thank you for watching. Have a good day. Take care.